All right, so now that you know about double angle identities, let's talk about half angle identities. And here are half angle identities. You'll notice the square root involved in these, and a plus or minus for all of them, just because of the square root. So this first one says if we know what cosine is, and the angle is in quadrant 2, then find sine of theta over 2. So we are going to be taking a look at this one right here, and we need cosine in order to be able to do that. Well, this time we already have that, so I don't need to draw any triangles, which is kind of nice. I can just go ahead and get started right away. Now, we are in quadrant 2, and we are trying to find sine. So remember, in the unit circle, sine is y, and in quadrant 2, y is positive. So that means right off the bat, I know I'm going to be using the positive version of this. So I don't need to write plus or minus all the way through. My answer should be positive. So I'm just going to stick with the positive version of this. And we're going to go 1 minus cosine of theta over 2. So 1 minus negative 4/5 over 2. All right. Okay, so this really means 1 plus 1 minus a negative 4/5 is really 1 plus 4/5. So if we think of 1 as 5/5, then if we're putting these together, we should get 9/5 divided by 2. And then you might want to simplify what's inside the radical there. So I'm going to do that off to the side here. I've got 9/5 divided by 2, or multiply by the reciprocal, right? Okay, so this is really 9/10. So equals the square root of 9/10. All right, so now when we're square rooting, remember, if you have a fraction, you can square root the top and the bottom. So this would end up being square root of 9 over square root of 10, which is 3 over square root of 10. Now we have a little issue with the radical being in the denominator, so we're going to multiply by special form of 1 here. We end up with 3 root 10 over 10 as our answer. I can't simplify the 3 and the 10 any further. So there we go. We've just used a half angle identity to solve and find sine of theta over 2. Okay, let's try one more. Just make sure that this makes sense. This one has a little bit more to it. This one we're trying to find tangent. It seems like tangent is always a little bit trickier. So we're going to be using this one, of course. All right, so in this case, we need to know cosine. We're only given sine. And our value here, it looks like theta is in quadrant 3. So let me draw my picture here. Okay. Sine is negative 8 over 17. So opposite, negative 8 over hypotenuse, 17. Radius needs to be positive. And if you do a little math here, you're going to get 15 for this one. But that should be negative because we're in quadrant 3. So I'm going to use that as my guide. So to use this formula up here, we need cosine. So I'm going to write that out. Cosine of theta would be adjacent over hypotenuse. So negative 15/17. All right, now let's use this formula. To do this, we're in quadrant 3, and remember, we're looking for tangent of this. So tangent in quadrant 3 is, Wayne's just adjusting himself over here, switching positions. Okay, so we're going to go ahead and think about, is this positive or negative? Tangent in quadrant 3 should be positive because it's negative divided by a negative, or y over x. So my answer here, I should be just dealing with the positive version. So I don't need to write the negative, but make sure you check that all the time. So this would be 1 minus negative 15/17 over 1 plus negative 15/17. Okay. All right, so now when you simplify that, this is really 1 plus 15/17 on the top here, 1 minus a negative. So you're going to end up with 17/17 plus 15/17 gives me 32/17. And on the bottom, we would really end up with 1 minus 15/17. So 15 or 17/17 minus 15/17 would give me 2/17. Okay. Now you need to, it's probably easiest to just think about what's going on the inside of this first. So let's say 32/17 times the reciprocal. Okay, these cancel out. I get 32 over 2, which is just 16. Okay, so underneath the radical here we have 16. So I have square root of 16. And again, because we're in quadrant 3 here, tangent is positive in quadrant 3, so it should be positive 4. And that's my answer. That's it. Okay, I hope double angle and half angle identities make sense now.